I once bought a second proxy plan, a whole month of somebody else's product, to fix an error that turned out to be a hash character sitting in the middle of my own password. The log said failed, 11,000 lines of it, all identical. I read the top one, saw a status code I did not recognize, decided the exits were dead, and went shopping. The code was a 407. It means the proxy wants credentials and did not get any. The client had never URL encoded my password, so everything after the hash was thrown away before it left my machine. 2 hours and a month of somebody else's money for a 5-character bug. Why I am the one saying this? I sell mobile proxy lines, SIM cards on Singapore carriers, modems on a shelf in my flat, about $10 a month per line in carrier data, and another $50 in modem depreciations. So I sit on both ends of it. I see what my own gateway hands back to a customer when something breaks on my side, and I see what a target hands back on the days I am the one scraping. The two look identical in a stack trace. That is the entire problem. 2 machines, 1 status code. There are at least 2 machines between your script and the data you want. Both speak HTTP. Both can return a status code and a body, and neither of them signs its work. Your client catches whatever came back first and hands you one exception. By the time it reaches your error handler, the information about which box produced it has usually been thrown away. So people guess, and it is nearly always the same guess, which is that the proxy is bad because the proxy is the thing you paid for and the thing you can swap. Telling those two apart is the most useful skill I know in this work, and it comes down to about 6 signals. The 407 is always the proxy. Start with the easy one, because it is the only code in this business that is never ambiguous. 407 is proxy authentication required. Targets do not send it. They cannot send it because a website is not a proxy and has no standing to ask you for proxy credentials. If you are looking at one, the box that produced it is the box you are paying. It means one of a short list of things, wrong username or password, an address allow list that does not have your current address on it, a subscription that lapsed at midnight, or credentials handed over on the wrong scheme, which is the SOX 5 against HTTP mistake. The cause is not the point. Not one of them gets better if you simply try again. The 403 is almost always the target. A 403 is a refusal, and refusals are the website's business. You confirm it by looking at the furniture. A real 403 arrives with the site's own things attached, their cookies, their cache headers, a body with their branding in it, or their standard error page, or a JSON object shaped like the rest of their APE. A proxy that wants to refuse you does not usually reach for 403. It reaches for 407 about off and 502 when it could not get where it was going. There is an exception, and it is worth carrying around. Some gateways answer with 403 when you ask for a country your plan does not include, or a hostname on their internal block list. Those are spottable. The body is tiny, almost always JSON, and there is not one cookie from the target in the response, because the request never got far enough to collect one. The 429 is the interesting one. This is the code that genuinely could be either, and it is the one most likely to cost you a week. 429 from the target means you asked too fast. 429 from your provider means you went past the concurrency or the request rate your plan allows. Same number, opposite remedy. The tell is again whether the response carries the target's own things. A real one usually has a retry after header, sometimes rate limit headers naming the window and what is left in it, and a body written by somebody who works there. A provider 429 tends to be bare. Short JSON, a message along the lines of session limit reached, and often a header with the provider's name in it. Timing gives it away too. A target 429 has a round trip inside it because it went somewhere and came back. A provider 429 lands in 20 or 30 milliseconds because it never left the gateway. Get that one backwards and you will spend days carefully slowing your scraper down to fix a concurrency cap, which slowing down does nothing whatsoever about. Connect or read, and why nobody splits them. Now the errors that are not HTTP at all, connection refused, and a timeout that fires while the connection is still being established, belong to the proxy or the route to it. Nothing reached the target. A timeout that fires after the request went out is a different animal. The bytes left your machine. Something on the far end is slow, or is holding the socket open on purpose and dripping you a byte every few seconds to keep you sitting there. That is deliberate on plenty of sites. It cost them nothing and cost you a worker for the full length of your timeout. Nearly every HTTP client lets you set the connect timeout and the read timeout separately. Hardly anybody does. They set one value for both, and then the log says timeout, and the log is worthless. Split them. 5 seconds to connect, 30 to read, roughly. The exact figures matter far less than the fact that a timeout now tells you which half of the journey died. That single change has told me more about failing jobs than anything else on this list. A 502 from a proxy is not the site being down. When a proxy returns 502, it is telling you it could not reach the destination. Its own DNS lookup failed, or its connect to the target's port failed, or the target hung up on it partway through. That is a statement about the lag between the proxy and the site. The site itself may be perfectly healthy and serving everyone else in the world. You separate them by breadth. A 502 showing up on every target at once is the provider's upstream, and there is nothing on your side to fix. A 502 on one hostname while everything else runs clean is that hostname, or the route to it from that particular exit. The second case happens more than you would expect on mobile addresses because a carrier's route to a given host is not the same road your home connection takes. What the certificate is telling you, on a normal HTTP proxy, your TLS session runs directly to the target through a connect tunnel. The proxy shovels bytes and cannot read them, so a certificate error there belongs to the target or to your own trustor. If the error names the proxy's own hostname, your traffic is being terminated at the gateway and started fresh from there. That is an interception proxy, and you do not want to learn that after sending a login through it. Log the two legs in different columns. Here is the practical half of all this. Most people log one field, a string, usually the exception text, sometimes a status code. Everything collapses into failed, and failed is not a diagnosis. Log the proxy leg and the target leg as separate fields. What the proxy did, what the target did if it got that far, which exit you went out on, how long the connect took, how long until the first byte came back. That is 5 columns, and it turns a heap of failures into something you can group by. I ran a job that wrote exceptions as strings for 6 weeks. When the failure rate climbed, I could not answer the only question that mattered, which was whether the bad runs were piling up on a few exits, because the exit was never written down. I rebuilt the logging, ran it 2 days, and the answer was 3 addresses out of 40. A 2-minute answer if the field had been there from the start. Retrying the wrong one. This is where a misdiagnosis turns into money. On a 407, do not retry at all. Fail the run and make noise. It is a configuration problem, and no number of attempts has ever fixed a configuration problem. I have watched a worker pool produce tens of thousands of 407s in an hour, all of them identical. On a 429 from the target, back off, grow the gap each time, and honor the retry after header if they sent one. Hitting it again immediately is the worst available response because it extends the window they are counting inside. On a 429 from the provider, backing off per request achieves nothing. The gateway is queuing you. Cut your worker count instead. That message is about how much parallelism you rented, and waiting politely does not rent you more. On a 403, stop retrying with the same session on the same exit. The same everything gets the same answer. On a connect failure, retry straight away somewhere else. This is the one case where an instant retry is correct, because a dead route gives you no information and moving off it costs nothing. On a read timeout, one retry with more patience on the same exit. If it dies the same way twice, that host is slow for you and grinding at it will not change that. Where I come down, the retry defaults baked into HTTP libraries are wrong for anything with a proxy in the path, and I think you should turn them off. They were written for a world with one server on the other end, where retry 3 times on any error was sensible. Put a second machine in the middle, and that rule becomes a machine for retrying the wrong thing at speed. Write your own switch on the classification instead. Mine is about 20 lines. It has saved me more money than any provider I have ever moved to. Plenty of people will tell you that is over-engineering for a scrapper. I have seen the invoices that come out of the other approach. What I cannot always tell, some providers return their own errors dressed up as the targets. You get a 403 or a 429 with a believable HTML body and no marking of any kind, and from where you stand, it looks like the site turning you away. There is a trick that catches most of them. Send a request for a hostname that cannot possibly exist, a random subdomain of a domain you own, or anything ending in .invalid. Nothing out there exists to answer it. So whatever comes back was manufactured by the gateway, and you now hold a sample of what their fabrication looks like. Hold it against your real failures. Do the same with timing. Anything that returns faster than your normal round trip to that region never went anywhere. But I want to be straight about the limit. A provider that copies a real error body byte for byte and pads the latency to match is indistinguishable from the real thing, and I have no test to hand you for it. I caught one of those exactly once, and I caught it by accident. 2 different exits return pages that were identical down to a timestamp printed in the footer, and no site on earth serves the same second to 2 requests 4 minutes apart. The classification table I work from, and the log fields that go with it, are at proxyscraping.org. Subscribe for more on proxies for scraping.